goes over us changing different scenarios into algebraic equations. So there's going to be different problems that we look at, and we'll be able to see that some of them can be solved through using just numbers, and some of them can be solved through looking at algebraically how we would solve them. I'm going to have us come back to this explore activity. We'll come back to that one, but we're going to skip it for now. So one major idea is that when solving a problem like the one in the explore activity, which we'll look back at, you can use numeric or algebraic methods. Numeric methods rely on just numbers to solve the problems, while algebraic methods also include the use of variables. Numeric methods don't require knowledge of algebra and can sometimes be simpler. Algebraic methods become very helpful as a situation grows more complicated, since they organize the calculations done in the problem. So you're going to see in today's lesson that we're using some pretty simple scenarios, and they're probably very easy for you guys to solve just using numbers, but you'll see that when we get to the next section, it's going to be really helpful that we solve them algebraically. So we're going to start with simpler problems today so that when you guys get to the next section, you're able to solve them without having as much trouble as you would if you had to solve them numerically. So you're going to learn how to solve one-step equations and solve problems for which algebra may be preferable to numeric approaches. You may be able to solve some of these problems in this section without algebra. However, we will use both algebraic and numeric methods to help you learn the processes and notation. So one of the biggest things is the notation involved. One of the important parts of solving using the algebraic approach is to define a variable. You'll also write an equation and then solve it. So with either approach, we get a result that should be checked to see if it satisfies the problem. We should also be careful to answer the original question, which may or may not be the initial result from a numeric or algebraic approach. So in order to solve a one-step equation, which you guys should be familiar with, there are 3 steps. The first step is to identify the operation performed on the variable. The second step is to isolate the variable by performing the inverse, which you can also think of as the opposite operation, to both sides of the equation. The last step is to state the solution and check if it is reasonable. So when we go through the next set of problems, it's going to ask you to plug it in and check your answer. That is one way of doing it. However, when we do these problems, I really want us to think, once we have our word problems, does our answer make sense in the context of the problem? With the information we know, does the answer seem reasonable? So using that approach, you won't necessarily have to go back in and plug it in, but you're just going to ask yourself, does my answer make sense? Is it reasonable? Okay, so starting with the first one, it says a number is added to x. So we have x plus 5 equals 12. So to solve this, I would look at what is being done to the variable x, and I can see that 5 is being added. So that's step one, to check and see what is being done to that variable. Step two is to do the opposite or the inverse to both sides. So instead of adding 5, I'm now going to subtract 5 from both sides, and I get x equals 7. So to solve the problem, we used subtraction. So we can see that addition and subtraction are inverse operations. To check it, we would just go in and plug in 7 into the original equation. 7 plus 5, we want to make sure that that equals 12. Yes, 12 equals 12. Looking at the next example, this one says that we have a number subtracted from x. So if I have a number that's being subtracted from x, I'm going to do the opposite. So instead of subtracting 5, I'm going to add 5 to both sides. And I get 17. So to solve it, we used addition. And to check it, we can plug in 17 in for x and make sure that both sides are equal. And we get 12 equals 12. For the next one, we see that a number is multiplying with x. So remember from one of the previous sections that we have 5 with x directly. That means that 5 is multiplying with the x. So to solve it, we're going to divide both sides by 5. And we get 4. So to solve this, we used division. And we can check it. 5 times 4 will give us 20. In the next one, we have x is being divided by a number. So to solve this one, we can see that x is being divided by 5. So I'm going to do the inverse, which is to multiply by 5 on both sides. So we get x equals negative 100. So to solve this one, I multiplied. And to check it, we're going to have negative 100 over 5 equals negative 20. And yes, negative 100 divided by 5 is negative 20. So something that's important, when you solve numerically, you work backward from the result to the unknown using the inverse operation implied in the problem. When you write an equation to solve the problem algebraically, you work forward from the unknown using the operation. So we are used to numerically working backward. So because we're going to do the opposite, it's going to feel a little bit opposite of what you would usually do, but just realize that this is part of the process of switching our thinking from numerically to algebraically. And as you work through these, you guys will see that the actual text and setup of the problem is going to help guide us in how to actually solve algebraically. Okay, so for this one, it says Eli says that he needs only $225 more in his account When we look at this problem, more implies addition. To reach $1,875 necessary for a down payment on a car. How much is in his account? I'm going to have us write a little bit more than we usually would need to down for these ones, just so that we have the right thought process going into these. So when I read this problem, I can see that Eli's account is $225 away from the 1,875 needed. So to solve this, we would take away 225 from 1,875 to give us the current balance. So to find out his current balance, we would just take away 225 from 1,875, and we would get $1,650. So to solve it, we used subtraction. But remember—
Hey, I just joined.
Okay, thank you. But remember that when we are setting it up algebraically, we're going to use the inverse operation. So when we solve this, we're going to be using addition to solve it. And this is where looking at the original wording will help us. So for our addition that we have, we can think he needs $225 from his current balance to get the $1,875 necessary. So the first thing you want to do is identify what your variable would be. And the variable, what we're solving for, is going to be the current balance. So I'm going to have our variable be C, the current balance. Now, one thing that I want to point out is just the word balance alone, or the amount that he has, is not enough information, because when we look at the problem, we have two different amounts that we're looking at: his future amount of $1,875 and also the unknown amount that he has now. So we know that his current amount plus the 225 more will give us the 1875. So our equation is going to look like B plus 225 equals 1875. So this is our algebraic equation. One thing that you want to make sure that you do is you want to have your variable having something done to it. So what we don't want is what we would do to solve it, which would be 1875 minus 225, and just have B all by itself. That is not what we want, okay? Because what this does is it doesn't set up an algebraic equation, it just shows us what we would do to solve the problem. So make sure that you have your variable with an operation on the same side as it. Okay, for part C, we're going to go ahead and solve the algebraic equation that we have. So we have B plus 225 equals 1,875. So to solve it, we would subtract 225 which is exactly what we did in part A. And we would get B equals $1,650. The last thing for D is to check our work. So if we did it the old way, we would check our work by plugging in 1,650 into that equation right there. But I want us to think, is it reasonable? So looking back at our initial problem, he's 225 away from being at 1,875. Is it reasonable that his current balance is 1,650? And yes, that makes sense. His current balance does not have enough in it, so it would be the 1,650. Okay. Looking at example 2, it says you watch a show in which people compete against each other to lose weight. The trainer exclaims, "Down 7 pounds in 1 week." On a screen behind the contestant is his current weight, 168 pounds. So his current weight is 168, and we know that he decreased 7 pounds from last week. So it wants us to find out what his weight was last week. So I am going to have us start thinking about these problems algebraically right away. So what we want to solve for is his weight last week. So last week's weight. And I'm going to name that L for last week. So our variable is L. When we look at our problem here, down 7 pounds implies that we would be taking away 7, that we would be subtracting 7. So when we think about our setup for our equation, we're going to take last week's weight and subtract 7, and that will equal this week's weight, which is 168. We're going to go ahead and solve. So on the next page, you guys have C, which is just to solve the equation. So you're going to have L minus 7 equals 168. And then you're going to solve it by adding 7 to both sides. And so we get 175 pounds. Okay, so if this week the contestant weighs 168 pounds and he lost 7 pounds in the past week, it does make sense that last week he was 7 pounds higher at 175. So our answer is reasonable. Okay, looking at example 3. Again, I'm going to have us jump straight into doing it algebraically. This says your email account states that 3.36 gigabytes or 21% of your storage space has been used. How much total storage is allotted in your email? So it's asking for how much total storage is in our email. So total storage is what we are solving for. You don't want to say just storage, because just storage could be how much storage we're using right now or how much total. So you want to be specific. Now with this one, I like to have us look at this to help us guide. We know that 21% of the storage is 3.36. So I know that 21% of the total sorry, is 3.36. So I'm going to write this as 21% of T, because T is the total, is 3.36. Whenever you have the word of, that means to multiply. Whenever you have the word is or are, that is equals. And when we use 21% or we use a percent in an equation, we are going to change it to a decimal. So we have 0.21 of, we're going to multiply with T, equals 3.36. Now you can write it that way, or you can write it without the parentheses. Either way is good. So we're going to go ahead and solve the equation. We know that 0.21 is multiplying with T. So to solve it, I'm going to divide both sides by 0.21. And I get exactly 16. And we're going to use our label here. So we have 16 total gigabytes. The last thing I'm going to do is make sure that it makes sense. If 21% is 3.36, then yes, it makes sense that the total amount would be 16. Okay, looking at our next example, it says you're reading the newspaper and see home value assessments. Your house is listed at $42,340. Assessments are 1/3 of the true value of the home. What is your home actually worth? So with this one, you are going to, I like to use that sentence right there. That's going to help us a lot. So we're trying to find what the home is actually worth. So let's say the true value, and let's have our variable be T for the true value. Okay, when I look at this one, it says assessments are 1/3 of the true value. So your assessment of 42,340 is 1/3. So R is the same as is, so equals 1/3 of, which means to multiply, the true value of the home, which we identified true value as T. So I'm just going to write that equation. 42,340 equals 1/3 times T. You can write it that way, or you can write it as T over 3. Either way works. Also, if you do not like the variable on the right side, you can rewrite it having the variable on the left. So we'll go ahead and do that right here. 1/3 T equals 42,340. Now, to solve this, remember that you can also think of this as T over 3. So 1/3 you can think of as, and they tell us in the next one, in the next sentence right here. And I'm going to have us look at that before we solve this. It says, if you have a one-step equation in which a variable is multiplied by a fraction, as is the case with number 4, you can undo the operation by dividing by that fraction, but you can also multiply by the reciprocal, all right? So that's going to be helpful. So I'm going to multiply by the reciprocal, which is the same as multiplying by 3/1 or just 3. So you would just multiply both sides by 3, because remember, 3/1 and 3 are the same. So that cancels everything out over here. And now I just have 42,340 times the 3. So I get $127,020. We're going to ask ourselves, does that make sense? Well, is 42,340? Does that seem reasonable that that is a third of the true value of $127,020? Yes. Okay. The next one says only 2/3 of the class was present on Friday. If 16 students were present, how many students are in the class? So I'm going to have us start solving it algebraically. Only 2/3 of the class, 2/3 of means multiply, class was, same thing as is, and then you have the amount that was present on Friday, which is 16. So make sure that you look at what you're solving for. How many students are in the class? So we want the total number of students. And so if I use this setup, I'm going to have 2/3 of, and I'm going to multiply with my variable t, the class. So 2/3 of the total students in the class were present on Friday, and that number of students that were present on Friday was 16. So my equation is 2/3 of the total, equals 16. I'm just going to solve it on the same page and not jump over to the next page for you guys. So if you have 2/3 times t equals 16, I'm going to use the reciprocal to solve it. So I'm going to multiply by the fraction flipped. So I'm going to multiply both sides by 3/2. Everything cancels out over on the left. And you're just going to take 16 times 3/2. And you would get 24. And make sure that you include your label. So there's a total of 24 students. Last thing is to check and see if it is reasonable. If 16 is 2/3 of the class, is it reasonable that the total? What was that? Sorry, it just flipped at me. I don't know if anyone was talking. Is it reasonable to think that the total class would be 24 students? Yes. Okay. You are not going to have to worry about these problems on your next page, but we're going to go back to the explore problem at the beginning of your notes here. So this explore problem says, Aaron runs a concession stand for a high school football game. She wants the prices to be whole dollar amounts that already include 6% sales tax. For each item in the table, the price for the customer is given with the sales tax included. What is the actual price for the item before the tax is added? So we are looking for, I'm going to call it the before tax price, and we'll have that variable as B. So we are looking for 6% more than the price before tax, and we want it to equal the given amounts. I'm only going to have us do 2 of these different items. We'll do the regular hot dog and we'll do the combo meal. All right, so for the regular hot dog, in both of these situations, you guys are going to be looking at percent increase. And with percent increase, you're going to be using a multiplier. So if we are looking at tax, we're going to have our multiplier have an increase of 6%. So it's going to be 1 plus 0.06, which will be 1.06. So I'm going to think of this as I want 1.06 of the cost before the tax to equal the $2. So this is my equation for my regular hot dog. All right, so to solve it, I am going to divide both sides by 1.06. And I end up with 1.8867. So let's round to the nearest penny, and it would be $1.89. So $1.89 plus 6% in tax will give us a nice even $2 item after the tax is applied. Okay, let's go ahead and now do this for our combo meal. I'm going to use the same exact setup, but now I want the final price to equal $5. That's the final price of our combo meal. So for this one, you're just going to take and divide by 1.06 on both sides. And you get 4.716, which would round to $4.72. Okay. We are going to, that ends our section 11 notes. And now we are going to jump to your section 13 notes. All right, so with section 13, I apologize that if you guys have not eaten dinner yet, that you will probably get very hungry while we work through these problems. But they are, like, legitimately, these are good ways to think about these problems. I really like the set of notes that we have here for section 13. Okay, so before we begin, we're going to look at different ways to repeat the following calculations. So for this one, it says to increase a number by 5 and then by 35%. So if you increase a number by 5, you are adding 5. It says and then 5%. So you want to make sure that you apply the 35% after you have added 5. So you want to make sure that you put that in parentheses. If you increase by 35%, that's going to be 1 plus 0.35 or 1.35. And you can put that 1.35 before or after the parentheses. Okay, in B, it says to increase a number by 35% and then by 5. So if you're increasing a number by 35%, you're going to have 1.35 times that number x, and then you'll add 5. So there is not any necessary parentheses here because you're multiplying first. Okay, with this next one for C, it says, and I'm actually going to have us, C and D are a little bit beyond what we'll worry about. So we'll skip those two. So now that you've learned how to solve basic equations by undoing operations, which we learned about in section 11, we can focus on using that skill to solve problems. In this section, we will concentrate on writing an equation to represent a situation and then solving it using skills you learned in the previous sections. So to do this, you are going to use a skill that we just practiced in the Explore activity, which is how to write an equation. All right, again, I apologize if you are hungry. Example 1 says, a local bar and grill is having a quarter wing night during which chicken wings cost a quarter each. As you leave home to join your friends there, all you grab is a $20 bill along with your ID, phone, and keys. We better add mask. Okay, so we'll make this 2020 friendly. Determine how many wings you can purchase if you also want to buy a pitcher of your favorite beverage for $5. If you are over the age of 21, I suppose you can decide what that favorite beverage, that pitcher would be. Be sure to be specific when identifying a variable. Letting W stand for wings is not specific enough because is it the cost of the wings? Is it how many total wings that we have? We want to make sure that we are specific in saying exactly what about the wings. All right, so if we look at this numerically, we would look at the fact that we've got a $20 bill, and this is assuming there's nothing else that we have to worry about. Assuming we don't have to worry about tax or tip or anything else or any sauces. You don't have to worry about any of that. It's all part of it. Okay, so, because don't worry, we'll get to that stuff. So first off, we have to account for the fact that we're getting our beverage. So I'm first going to take away the $5 for the drink. And I've got $15 left now. So if I have $15 left and I know that the wings each cost 25 cents, the second thing I'm going to do is take 15 divided by the 25 cents. So 15 divided by 0.25, I get 60. And this would be our amount of wings. Holy moly. 60 wings. So one thing I didn't do is I did not say what W would be, and W is the number of wings that we would order. Okay, so I'm going to have us write an equation where W is, oh, and it says it right there. I forgot that it says that. W is the number of wings, and we're going to solve it and answer. So if I know that 25 cents is the cost per wing or of each wing, I'm going to have 0.25 W plus the cost of the pitcher to give me the total amount that I'm going to spend. which would be $20. If I were to go through and to solve this problem, I would first subtract 5 from both sides, and we would have 0.25W equals 15. Divide both sides by 0.25, and we would have 60 wings that way as well. Okay, so notice that in the numeric approach, it involved dividing 15 by 0.25. This was the same calculation used to solve in the algebraic equation. For this first situation, both of these approaches are reasonable and fairly fast. It's pretty reasonable to do either the numeric or the algebraic. However, many important considerations were omitted from this problem, like we said with the tip and the tax and the sauces and everything. And the number of wings you would purchase is quite large. Yeah, 60 wings, that's a lot. So we're going to start to include some of those details, starting simply and then building for our most realistic situation. So this one, same idea. Suppose that you would like to buy your pitcher for $5. You also want to buy blue cheese dressing for $1.50, and then use the remaining money to buy wings. So in this situation, I'm first going to take away the $5 for the pitcher. And then I'm going to take away $1.50 for the sauce. So now I have $13.50 left. So with my $13.50 left, I'm now going to divide by 0.25 to get how many wings I can get, which would be 54 wings. So my equation is going to look pretty similar to this one. I just also have to account for the dressing. So I'm going to have 0.25 W for each wing, plus the $5 for the beverage, plus $1.50 for the dressing, and that will give me a total of $20. If you wanted to, you could combine the 5 and $1.50 to get $6.50. So you could write it that way. It's just not necessary. We would go through and we would solve it just the way we did the other one, and we'd see that we'd also get the same answer of 54 wings. Okay. For example 3, it says, notice that your friend's method, so it wanted us to go through and look at tip and everything. If we did 20%, so think back to our tax problem. If we were just finding 6% of the $2, it wouldn't be the right amount because we wanted 6% of the price before the tax was added. So you want to be careful when we look at the percent increase to have it represent the final amount. So in this one, it says, notice, don't worry about that part. Solve the problem again with the goal of leaving a 20% tip after buying the pitcher and the dressing, and then as many wings as possible. So the tip is going to be added or applied to everything. So we're going to have our 0.25 W with the $5 pitcher, with the $1.50 for the dressing, and it will be all equal to $20. We do need to apply a tip though, and our tip is going to be it's going to be an increase. So it's going to be 1 plus 20%, which will be 1 plus 0.20. And it's going to go on the outside because everything will have the tip applied to it. So this is going to be how we apply the tip to everything that we ordered. Okay, now we're going to go ahead and solve the problem. So you can see that 1.2 was applied to everything on the left. So I'm first going to divide by 1.20 on both sides. And that will cancel everything out on the left for the 1.2. So we have 20 divided by 1.2. So on the right side, we get 16.66 repeating. I'll just use 3 decimal places for now. And we still have what's left on the inside of the parentheses. And I'm going to go ahead and add those two together. Okay, now we just have a two-step equation. So I'm going to subtract 650 from both sides. So we have 0.25W equals, and we would have $10 and 0.167 left. Okay, the last step is going to be to divide both sides by 0.25. And we get a decimal. So we get W equals 40.67. Now, you are purchasing the most amount of wings that you can while still leaving a 20% tip and while buying your favorite beverage and while getting the blue cheese dressing. You do not want to be short on money. So in these problems, even though we would normally round 40.6 something up to 41, we don't want to be short in how much money we have. So I am going to always round down with these ones. So this is going to be 40 wings because we don't want to be short on money. Okay. Our next problem says for the most realistic result, we also need to incorporate sales tax. Assuming you will pay 7% sales tax and you want to buy a pitcher dressing and as many wings as possible and also leave a 20% tip, which includes the tax, how many wings can you order? So you normally, when you equate your tax and everything else, you're not going to worry about the tip being applied to that. But for the sake of these problems, we can't completely get rid of applying either the tax to the tip or the tip to the tax. So for the sake of consistency, you're always going to have the tip on the outside. So the tax will be applied on the inside. The tip will be applied on the outside. So I'm going to go ahead and set up my equation where I have 25 cents per wing plus I'll even just do $6.50 now because we know that the 5 and the $1.50 give us $6.50. And we're going to first apply the tax. So if we have tax, that's also an increase. So it's going to be 1 plus 7%, which is 1 plus 0.07. And then on the outside of that, we are going to apply the tip of 20%. And that all together will give me the $20 that I will spend. Okay. So this is a big thing here. We've got 25 cents for the cost of each item. We also added $5 and $1.50 for the different items that we bought other than the wings. Outside of that, we have tax and tip that were also applied. So we made those into multipliers using 1 plus the percent as a decimal. We used the tip on the outside part and then the tax on the inside part. Okay, so that gave us everything that we needed. Now we just need to solve. So I'm going to undo the outside part first. So I'm going to divide both sides by 1.20. Okay, so 20 divided by 1.2, we get 16.667. We still have the 1.07 over there. Okay, the next thing I'm going to do is divide both sides by 1.07. I still have the 0.25W plus 650. And now the right side is $15.576. We'll worry about rounding at the very end. Okay, I'm going to go ahead and now I don't have parentheses to deal with. So I'm going to subtract 650 from both sides. And we get 9.076. Okay, the last thing I'm going to do is divide by 0.25. And I get 36.305. We want to round to a whole amount. And remember, you're always going to round down because you want to make sure you have enough money. So we have 36 wings. In my opinion, that's still a heck of a lot of wings. All right, when we started our problem, we had 60 wings that we could buy, but we weren't worried about anything. All that we had was a drink. We didn't have dipping sauce. We didn't have tax or tip either. So, all right. So with example 5, we're going to go ahead and set up a similar problem to what we were working with, but we're going to change some numbers around so that you guys can see how straightforward and like how this follows a method and a rule. So if the price per wing is now 40 cents and the price for a pitcher is $5.50, how many wings can you afford for $20, assuming you are paying 7% tax and leaving a 20% tip? And we're going to assume that we still are going to buy the $1.50 dressing. So if we look at our previous problem, we've got that right there. So I am going to change the inside first. I'm going to change that to 0.40W. And now we have plus 5.50 plus $1.50 on the inside. So I just changed the inside to be 40 cents per wing, and I also included the new price of the pitcher and the price of the dressing. Now it says that we have a 7% sales tax still being applied. So on the inside, you're going to apply the sales tax. And then I'm going to use a bracket because we already used parentheses. And now I'm going to leave a 20% tip as well, so 1.20. And all of that will be equal to 20. Okay. We're going to go ahead and solve. So I'm first going to divide both sides by 1.2. And I get 16.67 while I write the left side. I'm going to add those together. 5.50 and $1.50 give me 7. Okay, the next thing I'm going to do is divide by 1.07. And I get 15.57. Next, I'm going to go ahead and subtract 7 from both sides. Write it over here. Sorry, running out of room. 0.40W equals 8.57. And the last step will be to divide by W. Or sorry, to divide by 0.40. And we get 21.44. Remember to round down, so we get 21 wings. Okay, in the Connect problems, these ones have you guys using decimals. We are not going to be looking at those at all, so you can totally skip those. But I am going to have us, so this is just to really look at dealing with decimals, but I feel like we've had a lot of practice dealing with these decimals in the problems above, so you guys should be fine. I am going to have us do the next few problems together to get some examples, but we should be done by 7:30 tonight without a problem. So definitely before that, probably around 7:20, maybe a little bit. I don't know. I'm not going to make any promises. I'm sorry. All right. So Value Rent-A-Car rents a luxury car at a daily rate of $38.57 plus 5 cents per mile. A business person is allotted $110 for the rental car each day. How many miles can the business person travel on the $110? So we know that we're looking for the number of miles. We also look at this and we know that there's a base cost. So this is something that's just added to the overall cost of $38.57. Plus there's a fee per mile. And 5 cents if we want to, this is written in dollars and cents, so I'm going to change this to be 0.05 because we want to have it in the same amount. All right, we're going to have, we know that everything will equal $110 in the end. And we know that 38.57 is being added. And when it says per mile, we know that M is for every mile. That means multiply. Okay, so this is my nice and fancy equation. Okay, I'm going to go ahead and solve it. So I'm going to subtract 38.57 from both sides. So 110 minus 38.57 equals 71.43. And the last step is going to be to divide by 0.05. And we get 1,428.6. We don't want to go over though, so I know that it looks like we would round up, but we're going to round down. So it's going to be 1,428 miles. Okay. Number 12. After a lady is seated in a restaurant, she realizes that she only has $44. If she must pay 7% sales tax and wishes to leave a 20% tip, what is the maximum price of the lunch that she can order? So for this one, we'll have it be P, and we'll have the max price of lunch before the tip and the tax. So this one, it's not worried about any specific items. It just wants to see, hey, before the tax and the tip, how much can she end up spending on the lunch? And we know that in the end, it's going to equal a total of $44 because that's how much she has in her wallet. And we're first going to apply the sales tax. The tip is going to go on the outside. So it's going to be 1 plus 7% for your tax. So that's going to be 1.07. And then you're going to, on the outside of that, apply your tip. So that's 1 plus 20%, which would be 1.20. Okay, so this is your equation. And now you're going to solve it. So first divide by 1.20. And we get $36.67. And then divide by 1.07. And you get 34.267. Remember, you want to make sure you have enough, so you're going to round down. So 34.26 is how much her meal can be before the tax and the tip. Okay, just 4 problems left. Emma has $170 to spend at a music store. How much can she spend on items if there is a 5% sales tax? Okay, so this one is kind of like the problem that we did with the price before tax when we looked at the concession items. So sales tax of 5% is going to be 1 plus 5% as a decimal, which will be 1.05. Let's first define our variable. And so that's going to be how much she can spend before tax. So this is going to be, let's just say A, the amount before tax. All right. So we know that the total will be 170, and there's going to be only 5% sales tax applied. So it's going to be 1.05 times A. So it's a pretty straightforward equation. To solve it, divide both sides by 1.05. And we get 161.904, round down, so $161.90. Okay. Number 14. An online retailer is selling used books for $6.49. You have $50 to spend. How many books can you buy if you must pay 6.5% sales tax and 10% for shipping? All right, so it says with the tax. So the shipping, just like your tip, is going to be on the outside. All right, so if we have our, oh, and it says how many books can you buy? So let's say B equals the total books you can buy. So we know that each book costs $6.49. I don't have any other items being added, and I don't have an exact amount of anything, like it doesn't say shipping is $4.99 or anything like that. So I only have percents that are going to be applied to this. And I know that everything will end up equaling $50 because that's how much total I have to spend. So the only other things that I'm worrying about are the 6% sales tax, or 6.5% sales tax, and the 10% for shipping. So 6.5% sales tax is going to be 1 plus 6.5% as a decimal. Now just be careful. That's 0.065. So on the outside, it's going to be 1.065. And then you also have the shipping, which is 10%, an increase of 10%. So that would be 1.10. Okay. Open, I'll close those, sorry. Oh, I closed them on the wrong side. Sorry about that. You'll have them closed on the left with your variable. Okay. Next thing you're going to do is divide by 1.10. And you get 45.45. Okay, I'm going to end up working over here because I ran out of room. Next thing we're going to do is divide by 1.065 on both sides. We get 42.68. And the last thing I'm going to do is divide by 649. If you wanted to, you guys technically could just keep dividing. You could take 50 divided by this, and then divided by this, and then divided by this. So work from the outside in. You just want to make sure that you're careful about the order. So this one did not have anything added or subtracted at all on the inside. So we could just do divided by this, and then divided by this. So we get B equals 6.57. Now, be careful. You only have $50 to spend, so you have to round down. So this would be 6 books that you could buy. Okay. For number 15, suppose you want to treat your office to lattes at a local coffee shop. The drinks are $4.75 each, plus you plan to buy a $4 scone for yourself. You also tip the barista 10% and have to pay a 7.25% sales tax. How many lattes can you afford if you have $65 to spend? Okay, so I'm first going to change these to percents, or change these to multipliers. So this one would be 1.10. This one would be 1.0725. Okay, on the inside, so I know that I'm going to have those. Oh, and also we want to define our variable, which will be L, which will be the number of lattes. So on the inside, because I'll have the tip on the outside and then the sales tax after that, I'm going to have my $4 scone and the $4.75 for each drink. So each drink, just like each book was $6.49, each drink is $4.75. So that will be multiplied with my variable. I also have a scone that's being purchased for $4. So that will go on the most inside part. Next, I'm going to apply the tax, and then I'm going to apply the tip. And I know that all of it will end up equaling the 65. Okay, with this one, you have to first, you can't just divide, because you have the +4 on the inside there. However, you have these two parts on the outside. So I'm going to have us use that shortcut. We can divide by 1.1 and divide by 1.0725. You can't do anything else though, so don't divide by more than those. Make sure you do 65 divided by 1.1 first, and then divide by 1.0725. Okay, so all we have left is the 475L plus 4 equals. And after I divided by both of those, I have 5509. Okay. Next, subtract 4. So 475L equals 5109. So divide both sides by 475. And you get 10.75. Now remember that you want enough money, you don't want to be short. So this would be 10 lattes. Your last problem for today. Suppose you get a $120 music gift card. Each song is $1.49, and you also have sales tax of 7%. How many songs can you buy with the gift card? So let's go ahead and define our variable. So let's have it be N equals the number of songs. I know that everything will end up equaling the 120. Now each song is $1.49, and we don't have any other additional charges, nothing being added or subtracted. And the only percent change that we have is the 7% sales tax. And so that as a multiplier will be 1.07. And that's it for that one. Now with this one, to solve it, it's going to be nice and straightforward because you guys have 1.07. You only have things being multiplied here. So you can take that shortcut of dividing by both of them. Just make sure you first divide by 1.07. Okay, so 120 divided by 1.07 divided by 1.49. And you end up with, whoa. Oh, I typed it in wrong, sorry. I accidentally hit multiply and I'm like, that's not right. 75.26, so round down, 75 songs.